separate. నెక్స్ట్ తర్వాత వీళ్ళకి కూడా ఉపయోగపడింది చింటూ వాళ్ళు.
Hello. Hello. Hello.
Yes, sir.
Are you getting my voice? Audible?
Yes, sir. It's audible.
Okay. So good afternoon to one and all. So
Good afternoon, sir.
good afternoon. Good afternoon. So I think okay. Today we will present the different types of transducers. Okay. So here we have a list of 36. Some are joining, some more are joining. Hello. So today we will discuss about passive transducers using inductive elements. So previously we are studied about different active transducers and passive transducers. Passive transducers using resistive elements, So in that we are studied about potentiometers, metal strain gauges. In metal strain gauges again two types: bonded strain gauges and unbonded strain gauges, and strain gauges using semiconductor materials. Today in this class we will see the passive transducers using inductive elements. So inductance, how the inductance will be changes. The inductance of a coil will depends upon the number of turns of the coil and the area encircled by the coil and length of the coil, and similarly the permeability of the coil. If any one of the parameters changes, then the inductance of the coil is also changes. So now I am showing some presentation here regarding the inductance. Hello. So coming to inductive transducer. So in this, hello Bobby. So if you have any problem, you can type in share, type in chat.
Okay, sir.
If you are not visible, not visible the presentation or any voice problem, you can share in the chat. Okay, I can see. Okay, so coming to passive transducers in inductive elements. So the inductance value is changes depending upon the parameters what we have discussed here. If the number of turns of the coil is changes, inductance will be changes. It means the increase of the number of coil turns of the coil increases, the L value, inductance value changes. Similarly, area of the encircled coil changes, then also inductance value changes. But L also changes, small l. Small l it means length of the coil, and the capital L is the inductance here. If the length of the coil is increases, the inductance value will be decreases. So there is inverse relationship between length and the inductance value. So out of this, for a fixed coil, the number of turns of the coil and area of the encircled by the coil and length of the coil are fixed. So the only change the possibility is the variability of the permeability. Suppose you can change the permeability of the material, then we can also observe the variation in the inductance value. So in this case, so there is a inductive transducer. So here, this is the core. When this and the core is surrounded by a coil, wounded by a coil, and if you consider the core is a permanent magnet or it is a soft magnetic material. So when this core is moving inside of the coil, that leads to production of the EMF. So it generates the EMF. So whenever the core is moving left and right, or if the core is having a displacement, that leads to change of the permeability of the core, because suppose the core is moving to the left side, that gives some air gap is filled in the coil, that causes the permeability of the core and permeability of the air changes, and due to that the inductance of the coil will be changes. This change in the inductance value will be observed by using AC measuring bridges. For example, Hay bridge. Hay bridge is used for measuring of the changing inductance value. Similarly, we have variable reluctance transducer. So in this variable reluctance transducer, so it is just opposite to the permeability of the inductance value, inverse of the permeability. So that's why it is having a inverse relationship with the inductance value, or is the reluctance. It is opposition to the permeability. Okay. In this case also there is change in the permeability, then also the reluctance of the coil will be changes. Based upon this also we can have a transducer, that is variable reluctance transducer. In this case core is constant. In this case core is constant. And another one very important and widely used passive transducer using inductive element is a LVDT. LVDT is nothing but linear variable differential transformer. It is a linear variable differential transformer. So LVDT, we can call it as LVDT. So linearly variable, so differential transformer. So generally transformer having a primary winding and secondary winding, whereas in this case in LVDT we have two secondary windings, and in between we have a core material. So this core material will move in between primary and two secondary windings. Here the secondary winding is connected as a uh, mutually it is series opposing nature. Series opposite we will connect, because the generated voltage between two secondary voltage will be subtracted. It means suppose this is the secondary winding 1, this is secondary winding 2. From the secondary winding 1 we will get the voltage of E1, and secondary winding 2, so from secondary winding 2 we will get voltage of E2, and by series opposing connection we will get difference of these two voltages. And another type of connection is there, that is series aided connection. In such situation we will connect it is in series nature. By that we will get the addition of the two voltages. So but here we will connect it in series opposition nature. Due to that the generated two voltages E1 at secondary 1 and E2 at secondary 2 will be subtracted. Due to that, if there is any non-linearity effects present in the coils will be cancelled out. Due to that we will get the linearized output. We will get the linearized output. So here consider initially this core is in between two equal distance between two secondary windings. In such situation, when we apply the carrier signal at the primary winding or primary side, that secondary voltage will be produces the magnetic flux. That magnetic flux will crosses through the secondary windings, and due to that the EMF will be induces in two secondary windings. Due to the core is present at the center of the two secondary windings, we will get two equal voltages at E1 and E2. Whenever these two are subtracted, we will get the zero voltage. It means the core is at minimum at middle of the two secondary windings, that leads to production of zero voltage. That is equal distance between the two secondary windings. If the core moves any direction, it means positive upward direction or downward direction, or displacement is moved. Displacement is there, some positive or linear way, or the left or right or up and down. So depending upon the application, we can place this LVDT as a horizontal movement or vertical movement. Suppose assume that this core is placed as a vertical position. If the core is moved upward position 1, this is the, as a dotted line indicated, it is a upward position. At this moment, at this stage, the core is very near to the VS1, secondary coil 1, and most of the core is covered with the secondary winding 1, but secondary winding 2 is not covered, not much more that one. So in such situation, most of the voltage will be produces to the VS1, and very less voltage or less core is covered with the secondary winding 2. Due to that, the voltage generated at secondary 2 is less, and the voltage produced at secondary winding 1 is higher. So we will get higher voltage of positive value. So this means, so the voltage at Vs to E1 and Vs to E2, the difference of these two will produce as the higher voltage. Suppose the core is moved very far away from the Vs2, then most of the flux will be coupled with the Vs2, and due to that we will get the most of the voltage ES1, and this is the 0. So that is the maximum value. So this, the dotted line indicates the position number 1. So at maximum position, maximum value of the core, if the most of the core is near to the VS1, we will get the most of the voltage at the output. Similarly, if the core is moving downwards direction, so this is the downward direction. It means the voltage is decreasing at secondary value. And suppose from the center position to core is moving to downward direction, then the core mostly will covers the secondary winding, and due to that, most of the voltage will be produced at the VS2, and VS1 at this point, the most of the voltage at VS1 is 0, and maximum value of the VS1 is at this point, and like that, depending upon the core position, the voltage will be generated. And here we have a and here we have um, the generated voltage. Here this is the AC modulated signal. This is the modulated signal, and this is the um, DC voltage. So here we have a phase change is there, and this phase indicates the direction of the displacement. So in which direction it is moving. Okay, so it indicates the direction of the core movement. So phase only indicates the direction. Okay, if it is positive or negative, or it is moving upward downward direction. In such way, okay, like that we can measure the displacement by using LVDT, linear variable differential transformer transducer. So it is also a passive transducer, because for controlling the carrier signal, we are applying some external carrier voltage here. So with this controlling of this carrier voltage, we can measure the displacement. Okay, and coming to the next one. And, next one type of the transducer, passive transducer, is passive transducer using capacitive element. Capacitive element. In this case, so generally the capacitor is a combination of two plates, and in between we have a dielectric material is filled. So this dielectric material will separate two charge carriers on left side and right side. So equal charges will be placed at the two capacitive plates. Suppose if any of the parameter will be physical parameter of the capacitor changes, then there is a change in the capacitance value. So from the basic equation, C is equals to epsilon A by D. Epsilon A by D. So C is equals to epsilon A by capacitance, and epsilon is the permittivity, and A is the cross-sectional area of the plates, and D is the distance between the plates. If any of these physical parameters are changes, the capacitance of the capacitor will be changes. Based upon that, we can develop a capacitor transducer using passive nature. So suppose these are two plates. If any of the, suppose assume that this plate is fixed, this plate is fixed, and the second one is movable plate. Suppose we have to apply some displacement in the right side direction, and that member or core is connected to the movable plate. If the core or the movable plate will connect a displacement to the plate, and due to that, by the application of the displacement, this plate will be moved right side direction. Then what happens? The distance between the two plates will be increases. Due to increase in the displacement, there is a change of the capacitance. The change in the capacitance can be identified by a rectified bridge circuit, AC bridge circuits uses. AC bridge circuit, by using AC bridge circuit, we can measure the change of the capacitance value. So in this case, if this is the fixed plate and this is the movable plate. Suppose we are applied some displacement over this plate, then this plate will be moved to right side direction, and the distance between the plates will be increases. If the distance between the plates increases, that leads to decrease in the capacitance. Distance, because these two are in inverse relationship. Due to that, the distance between the two plates increases, the capacitance will be decreases. Okay, based upon that, we can develop a transducer for measurement of the displacement. If suppose the the displacement is applied on the left side direction, then the plates will be moved to the movable plate will move to the left side, and due to that, the distance between two plates will be increases, and in such distance increases, the distance between the two plates will be decreases, and due to that, the capacitance will be increases. Like that, we can use this capacitor as a linear displacement measurement device. And another one is another type of the capacitor transducer is a, so here another parameter is area. Here area is nothing but the cross sectional area of the plates. Between the two plates, the area of the two plates and the cross sectional area of the two plates means overlapping area of the two plates. The overlapping area of two plates is same, so at that time we get some capacitance value. The overlapping of the plate is changes. If any one plate is changes its position from down to upward direction, then the overlapping area is changes. If suppose the area is decreases, then the capacitance will be decreases. Like this, if the overlapping area between two plates is increases, that leads to increase of the capacitance. And similarly, the material, dielectric material which is present in between the two plates is nothing but dielectric material, and it is having some constant value. If the two plates are fixed, but the dielectric material is changes its position from left to right or up to down. So in such situation, the dielectric material will be changes its position, and due to that also there is a change in the permittivity of the material, and due to that the capacitance of the capacitor will be changes. Like this, based upon these three physical variable changes, so there are three types of capacitor transducers can be used as a passive transducers. In all such situations, we can use the carrier signal as this carrier signal as some excitation voltage, and with that control of that excitation voltage, we can identify the variation of the capacitance by using some meters, deflection meters. What we can see in what we can see in Wheatstone bridge, like that. There is a deflection meter will be fixed in between the terminals. and if a variation of the capacitance will be measured. The one of the measuring capacitance measuring bridge is scaling bridge, and for the inductance it is Hay bridge. For inductance measurement it is Hay bridge. For capacitance measuring it is scaling bridge. Okay, and coming to next one is, so up to now we are seeing passive transistors using different passive elements like resistor, inductor and capacitor elements. We can also develop the passive transistors using active circuit elements. Active circuit elements are nothing but, generally the active circuit elements are vacuum tubes, and transistors are considered as active circuit elements. So active circuit element provides power gain for a signal. By using the transistors we can obtain the gain will be increases. In some configurations the gain will be increases. Like that we can get the power gain will be increases by using the active circuit elements. With that we can get the more power using the active circuit elements. So, and these are used as a transducers. Okay, and the one we can consider as a vacuum tube based photoemissive transducer. So this is photoemissive transducer in nothing but which converts the photon energy into the electrical form of energy, and also it emits the electrons. Whenever the photon energy will fall on the electrodes, it emits some electrons, and due to that, if we collect those emitted electrons, and which forms a current. So in such way we can convert the photon form of energy into the electrical form of energy. So here the best example for the photoemissive transducer is a photomultiplier tube. So here the generated electrons will be multiplies the number of times, multiplier, because the name itself indicates the multiplication of the induced electrons. So if you see this figure, so we have this is a photocathode, and this is the window, and this is the focusing electrode, and this is the incident photon energy. So we will allow the photon light energy through this window and falls on the photocathode. After fall on the photocathode, this cathode will emit the electrons, and those electrons will be falls on this particular voltage. And how we will connect that electrons means using some, finally we will connect to the anode. So in between we have some electrodes. These electrodes are called as these electrodes are called as diodes. This is the one diode, this is another diode, this is another diode, this is the diode. So whenever the electrons are emitted from the electrode, these electrons will be attracted towards the anode by giving some higher voltages. So this diode having a 0 voltage, after that this is the 100 volts, this is the 200 volts, and this is the 300 volts. Like that we will increase the voltage. With that we can attract the more number of electrons. Once this electrode will fall on this, so it will be moves to diode 1, and from when it will be impacts with this diode, it will again divides into 2 electrons, and when these 2 electrons will be impact with this diode, again it will produces another 2 more electrons. Each one will produces 2 more electrons. Like that 2 electrons will become as 4 electrons, and these 4 electrons will, when these 4 electrons will impact on this diode, so at this moment again these 4 electrons will be produces another 8 electrons. Like that the number of electrons, generation of number of electrons will be increases, and finally at the anode we will collect all these produced electrons, and it will be measured by using some output meter. So this is ammeter. So this ammeter current will be indicates the amount of light intensity which is fall on the anode cathode. Okay, due to that the generated electrons will be increases, and the number of electrons depends upon the incident energy, that is photons energy. Okay, and here we will apply some power supply 100 volts, 200 volts, 300 volts, 500 volts, because to attract all these electrons, so you have to apply higher voltages, and from that we will collect the output current. This current will reflects the amount of photon energy is applied on the photocathode. So this is one of the best example using vacuum tubes, as the light energy will be converted into electrical energy using active circuit element. Active circuit element. Okay. Next. So next one is another one is a phototransistor. So phototransistor is nothing but if you connect a base for the diode, photodiode, so we will get the phototransistor. So for the photodiode we have two types, PN junction type diode. So when it is reverse biased PN junction diode, when it is reverse biased and photon energy will falls on the junction, so we will get the charge carriers, and with that we will get the output current. So similarly, when we place another base region, and that base region will be experience or the energy, the light photons will be falls on the photon energy base region, that leads to change of the charge carriers, that also produces the current. So students, so in my phone the charging is very less, that's why still now I am stopping here. So uh, please stay until I will take the attendance. And next time you can enter your roll number as your name. Please change your name into your roll number. Okay, some of the candidates are having only names. So here, this is who is this Siva? What is his number?
439, sir.
439. Okay, if you have a name, no problem, but you can also include your roll number. That's important to take that attendance. Four 426, 484. Okay. So with this, I am stopping my presentation. We will continue from tomorrow. Thank you.